Okay, this is the second part of section 2.3. So we're going to look at a couple of problems here. The first is, given this equation y equals x to the fourth minus 2x cubed minus 36x squared plus 48x plus 10, solve this, what we call a differential equation. So this is another way of saying the second derivative. So remember, the first derivative is written dy dx. The second derivative, which is the derivative of the derivative, is written this way. If we're using y notation, we can also write it as y prime, so just so you see a different way. So y prime would be 4x to the third, again we're using our power rule, minus 6x squared minus 72x plus 48. Now it's asking us to find the second derivative, so I'm going to write that as y double prime. So we get 12x squared minus 12x minus 72. So this is equivalent to y double prime. They want us to set that equal to 0 and solve. So I'm going to divide everything by 12 to simplify this quadratic. So we get x squared minus x minus 6. Fortunately, this factors x minus 3 and x plus 2. So applying our zero product property, we get x equals 3 and x equals negative 2. So in essence, we've just solved the quadratic equation, but that quadratic equation was the second derivative of this fourth degree equation. Okay, let's look at another problem here. F and g are functions, and they give you some values, f of 2, f prime of 2, g of 2, and g prime of 2, and they want you to find the following. So really what we're doing is we're applying some of our basic rules and properties. So here we have our sum difference, which basically says that we can write it as g prime of 2 minus f prime of 2. And g prime of 2 is 2, f prime of 2 is negative 1, and so that equals 3. And here we have a scalar, so this is the same as 3 times g prime of 2, and since g prime of 2 is 2, 3 times 2, 6. And here, a little more complicated, we have the product rule. So the product rule can be written as f of 2 times g prime of 2 plus g of 2 times f prime of 2. So there's our product rule. So f of 2 is 3, g prime of 2 is 2, g of 2 is negative 5, f prime of 2 is negative 1, so 6 plus 5, or 11. And now we have the quotient that's a division sign, so f divided by g. So remember, this would be g, because that's in the denominator, times f prime of 2 minus, and then we would have f of 2 times g prime of 2, all divided by g of 2 squared. Right, because our quotient rule is when we have f of x divided by g of x is g of x f prime of x minus f of x g prime of x, all divided by g of x squared. Okay, so g of 2 is negative 5, f prime of 2 is negative 1, f of 2 is 3, g prime of 2 is 2, and g of 2 is negative 5. Right, so we have 5 minus 6 over 25, or negative 1 over 25. All right, and our last problem that we're going to look at is a word problem. It says find an equation of the line perpendicular to the tangent to the graph of y equals x cubed minus 3x plus 1 at the point 2, 3. So if this line is perpendicular to the tangent, then the slope of this perpendicular line and the slope of the tangent line, they will be opposite reciprocal or negative reciprocals. So we have to find the slope of the tangent line first. So slope of tangent line, which means we have to find the derivative. So we have y equals x cubed minus 3x plus 1. The derivative y prime is 3x squared minus 3. So the derivative at x equals 2, 3 times 2 squared minus 3, so 4, 12. So the derivative at 2 is 9. So now the slope of a perpendicular will be the negative reciprocal, and we're still using the same point. So now the equation y minus 3 equals negative 1/9 x minus 2, and we can just leave it there in point slope form. So again, find the derivative, and this represents the slope of the tangent line to this graph at any x value. They specifically give us at the point 2, 3, so our x value is 2. So there's the slope of the tangent line. A line perpendicular to that will have the opposite reciprocal slope using that same 2, 3 point, and we put it into point slope form. Hope that helps, and we'll see you soon.